every year perhaps. So we can, after your feedback, we can change this program, orientation, whatever, what are the gaps, and then we'll once again get back to the next set of principles next year perhaps.
Professor Rajiv Banerjee, he is the president of the Innovation Council, and thus they together have organized this program. You know about Jadavpur University, some of you may be graduated from here, and Jadavpur University remains one of the premier university of the country despite all the other news that you get from the news media regarding Jadavpur University. And what
so we are always aware that based in line with MEP 2020 as well as based in line with State Education Policy 2023, particularly I was also the expert member of that particular committee which actually proposed the State Education Policy 2023, and I have adopted that particular concept from the MEP 2020, that is the introduction of the semester system at the school education.
The scientific knowledge from ancient to modern was polluted through many of them. That's why it was either filtered or polluted. This is one thing. So we have to be cautious. Although we are doing the MEP 2020, our university particularly remains very cautious to reframe their syllabus and their subjects and curricula, etc. So from that view, this is one thing. Secondly, in the science teaching, science engineering applied, and I am not aware of teaching model. That is for the history and chemistry. History is one subject, chemistry is another subject. One belongs to science, another belongs to art. How do we collaborate them? Then the emotional attachment with the scientists of the country as well as the reformer of the country, etc., can be involved in this. So we will discuss all these things in
this is very strange actually. We do maintain that.
The laboratory coordinator, so we force all the students, because if somebody fails in laboratory, it lost the issue. That is the system of our.
Till date, we are maintaining that discipline, that academic discipline, starting with the laboratory visit and laboratory everyday experiments. So that we strictly maintain, because
components, for example, the insulators, transformers that we use in our total power system structure. This was meant to be a testing laboratory for this equipment. Okay. Majority of the equipments were being tested here, and this laboratory was the extension of the main electrical engineering department, and this laboratory is being built totally a separate structure because it requires. Okay, we will just give the transformer the tested voltage, whether it replicates the lightning impulse voltage, that is when it is mounted externally, whether this voltage, the transformer can withstand these voltages or not. When the lightning occurs. The over voltage is there, so it just simulates that lightning here and gives it to the transformer so that the transformer can withstand it or not. And this line voltage, over voltage is generated and given to the insulators, whether it can withstand the over voltages or not. So that is the power frequency testing here. Here is the impulse, and beside there are some small testing, like there are several things.
This is the electrical machine laboratory.
This is how they control the speed of the train or trams. Same machine there. And in power plants of generator, we have this type of generator. This type of generator. This is the bigger version of that is used in power plants. Therefore, we have to accommodate 1,000 students per year, per week in this particular area. Therefore, for safety, we have kept only 110 volt AC. That is used, not 110 volt AC, which is used in railways for safety. The old system, but our teacher thought that 110 volts will be less dangerous for our students.
Where we have measured the distribution using a robotic instrument which can do a computer program which can rotate and it can measure the distribution from this light. In the 360 degree, that means it's a 3D plane actually. We can measure the distribution. This source is a very special type of source. Have you seen this source earlier? This is a yellow light.
Monochromatic.
Yeah.
Monochromatic. And why this is so important? Let us see.
So it's the large between the red and the violet color.
Right. It is at 589 nanometer. So the problem is that if you can see, just ma'am, if you can switch off the coming out as a light source. Why this is so important? You know, once we talk about that, we have the cases. Just one example I want to share with you that we talk about the efficiency of the LED. Even if you buy LED from the market, you don't know how much light output it actually gives. So this is the type of instrument, integrating sphere. You will see the special type of coating is there inside. It's a very special coating. Even in India nowadays, nobody provides that setup because
students.
they have been getting a lot of interest out of that. I know and they can relate because you know if we can take them to the high voltage or anywhere, this is a super specialty area. Initially, they will not be able to connect, and here they can show that. So that's why I thought I can show you also in our that. The next part, this is a assess that the how light distribution over a surface with a different height, we can do that experiment using this. This is a kind of measurement we call isolux diagram. From there, we can predict any luminaire whether that can be suitable for any lighting application or street lighting application. So that is being identified there. So primarily we measure in a two part. One we call visual measurement. Mostly in our plus level physics laboratory, if we perform the experiment, the optics laboratory, we are using lenses, mirror, prism, but human eye as a sensor. Now once the human eye is getting replaced with a photoelectric sensor, we call it physical vision. So that means in our this visual measurement, the only disadvantage is that here we are using human eye, so it will be individualistic in nature. It can be biased because I have some eye characteristics, so that makes it. But once you are measuring the physical parameter, you are using sensor. No matter whether I'm using or you are using, we are supposed to get the same result. It is there for different luminaire. It is very much important to know. This equipment is called mirror distribution photometer. So right now I am not showing the you can see here in a three-dimensional plane. So this is very much required for design. So here you can see the sensor part is there, and the other part of the sensor, there the mirror is there. So they are making a kind of couple, the entire arrangement. It will rotate and we can measure the distribution of light in a three-dimensional plane. We call spherical polar coordinate system, r theta phi plane. So there we can measure the distribution in a 3D plane. So if any type of luminaire you have, any type of light source you have, you can measure how light is distributed in all the directions. Okay. It automatically run, we have to go by this. That's all actually we use. This is a very unique thing we measure for R&D purpose and also for the industrial purpose. Different kind of projects we have, we measure it directly from here. We have many more parts. There's one thing I couldn't share with you, that just beside that we have one of our lighting laboratories. We call it physical measurement. So in that case, we are going to a physical photometry, physical related measurement. So we have that, but we compare both. So first part is a visual measurement where the student will come and they will find out. We have some instrument which will directly measure the quantity of energy present at each wavelength. So that is a physical part. Why? Because both the experiment have kind of merits and demerits. Like, you know, the visual measurement is very much individualistic in nature, because I have some capacity of eye, many of you have, so that may differ. So that's why there will be a chance that measurement can be individualistic in nature. Whereas once we are using a physical measure, we are using a sensor, it doesn't matter whether I am measuring or you are. So if the position is placed correctly, we are supposed to get the same result.
Yes. So I can go there. Then I think better.
I think you come and
Yes, you can see. Yes. Yes, I will show you again. So this is actually a chip. Inside that you will see small things, which is actually a chip. And inside the chip there is some pattern, which is a switch. You can cut them and you can make the bonding. Then it will act as a switch. Okay. Now this is actually created using MEMS technology, micro electromechanical system. Means a system where mechanical up down of a beam made on that. So these are actually a beam which is actually hanging. You cannot see it in a naked eye. If you space 65, 45, you can use space technology. 3 nanometer or below. Those chips were maybe small drones, then maybe some small spy cameras they are using. Inside is non-polished.
So you're using only silicon or germanium also?
We actually use silicon. Not only that, after this chip you made, that chip contains sensor and circuit. Then only it's a actual chip. Only a sensor, it is just a primary front end. But the final chip is the full one. So we used to create students the knowledge, they learn how to make it. We are using training program in summer and winter for undergraduate colleges and engineering colleges, where students are coming to train themselves using a silicon, how to handle a silicon to create a junction, and how to make a circuit in analog and digital one. So that any program we usually organize. Without hardware, you cannot think of implementing any AI code in any our systems, from our TV, smart TV to smart gadgets to LED lights to our, like I can say, one very interesting topic is mood swing light. It is already used in many institutes and companies. Mood swing lights.
Houses.
Yes. So this mood swing lights means you need some kind of gadget mounted with a sensor, means some kind of headphone that will take the brain signal. Then it will transmit a signal to the light sensor boards that will change the thing. So that means it needs AI, database and the implementation chip. So definitely you need the knowledge of implementation chip. Okay. So now we will moving to silicon. You need chemical vapor deposition. So that is the process by which we put graphene deposition. Using graphene, you can create insulator, you can create semiconductor. And not only that, stealth technology, where you can paint graphene with a pattern on a material so that the light reflect on it and it will not come back to me, so that there is no reflection. So that called intelligent reflecting surface. Using the voltage on this material, you can change the direction of the beam. So we call this technology used in 6G communication. So that is basically in that room. And using plasma, you deposit some kind of material. So creating plasma is an important thing. And remember, for that, a student should also have the knowledge of how a plasma should generate it, what is the electrons whole pair, how the electrons are rotating, clouds are formating, and also a bit knowledge about quantum. Now, quantum semiconductor, quantum theory, basics of quantum theory. Even if we studied PN junction, we have a EK diagram that is called energy band diagram. So that energy band diagram is actually what we studied in books. It's a partial thing. In actual, it is a quantum domain explanation.